Hi, this is Mr. Max here. What I'm doing today is I'm going to do quadratic expressions that are written in vertex form. The concept first of completing the square, I thought that maybe it would be best if I just can briefly explain. Let us take an expression, for example, and we take an expression a squared plus 6a plus 9. When you factorize this expression, you get a plus 3 times a plus 3, which essentially reads as a plus 3 all squared. So this here is a perfect square trinomial, because whatever value you input for a, whether it's a positive or a negative value, once you add it with 3 and you square that, the answer will always be positive and the answer will always be a square number. This is a complete square, as I said. So other type of examples are x squared minus 10x plus 25, y squared plus 12y plus 36. And I will show you exactly how you can quickly look to see whether this is what we call a perfect square trinomial. Well, we did the first one here. So what you do is you take half of the middle term. Remember, your standard form for a quadratic expression is ax squared plus bx plus c, where a, b, and c are constants, and obviously a cannot equal to 0. So the b I'm referring to here is this particular 6 here, or this negative 10 here in this particular expression, or this positive 12 here. So that is the value of b that I'm talking about. So you can quickly have a look, and you take half of b, and half of b, and half of 6 is 3. When you square that answer, does it give you 9? Of course it does. And if such a condition takes place, then it means that this trinomial is a perfect square trinomial. Half of negative 10, if you can see, half of negative 10, well, that's 5. If you square 5, do you get 25? Yes, you get 25. So this here is a perfect square trinomial. The same applies with half of 12, which is 6. And when you square 6, you get 36. So this is how it will factor. It is worth noting that all expressions are perfect square trinomials. When you quickly look at this, what I've done here with this particular one, you'll see that half of 6 is 3, squaring that gives us 9, but this is a 10. The same here, we've realized half of negative 10 was 5. When negative 5, when you square negative 5, you get positive 28. However, here you have to get that square completed, you need 25. Half of 12 again is 6. When you square 6, you get 36. So you are off by quite some number there. And the first expression here, as I just mentioned, is not equal to 10, but equal to 9. So there is like one more vertical translation, and I will explain this quickly by bringing in the graph, and then you can see what I mean by that vertical translation. The same with the second one. As I said, there's 3 more. 28 is 3 more than 25. So again, if you look at the two graphs and you compare them, you will realize there is a vertical translation, an upward movement of the whole graph by 3 units. The second one, comparing with the other one that I have done, I had 36 initially, but this is 9. When you subtract 9 minus 36, you will realize that what happens is the graphs go down by that unit. I'm just going to look at one specific graph if I quickly can bring that. So let's look at this in terms of graphs. So the black one that you have here is our graph a squared plus 6a plus 9. And if you graph that particular function, you'll see that it passes here at 9, okay? And it is also written as a plus 3 all squared. It's a perfect square trinomial. Also, you can see that it just touches at negative 3. But when you take the other one, what essentially it means is that it's the same type of graph, but it went up by 1, okay? Because that plus 10, it went up by 1. So it then cuts the y-axis, all right, these values here, this value here of 10. and the value here of 9. These are the indicators as to where the graph cuts the y-axis. Here the graph will cut the y-axis at 10. So the difference between the two graphs is like a whole 1 unit by 1 is that red graph went up with. So that's what I mean by a vertical translation. It went up vertically. Okay, and it is very important that you do realize that the graphs are similar and it went up different points where it cuts the y-axis. So I just wrote this just briefly as a squared plus 6a plus 9, which I know that this part here is definitely the function. So plus 1, that gives me the 10, tells me that the graph went up by 1. And again, when you take this part that I put under a rectangle here, you get a plus 3 all squared, as we have seen already, and the 1 indicates that the whole graph has been translated upwards. Now, what you also have here inside, and I like to call the stuff here inside brackets here, the stuff tells you the horizontal translation of the graph, whether the graph is going to the left or to the right hand side. So what you do is you take that stuff and you let it equal to 0, and you solve, and you will realize that, as you could have seen, that x is negative 3 here. That means my graph was translated to the left. So you must be a bit careful whenever you are, and later on I'll show when we talk about the transformation of the graphs, and when we talk about the turning point of a graph. So this information here, you equate it to 0. It tells you whether your graph is to the left side or to the right side. Because this graph could easily have, if I could just roughly, it could easily have had something that goes in this direction, all right? And then that means then the stuff inside here would have been negative. So I give you an opportunity to have a look through and compare these particular questions with one another. Let's look at a few exercises or that I use similar method. So what I have here is y equals to x squared minus 10x plus 28. Of course, the way I do it is I take this 28 first, and also it's an expression, so you can just put in y equals to, please remember, this is not an equation, don't let it equal to 0. We're not trying to solve for x, we just want to rewrite it from standard form into vertex form. So my method is take the 28 to the other side, so it's kind of in the way there, and then you are left with your x squared minus 10x. Now for this part, when the coefficient of x squared is 1, it's quite straightforward of what you're going to do. So what you take is half of the middle term. Remember, half of the middle term is negative 5 when you square that. So I've done it on the side, so you can see that if you take x minus 5 and you square that, the minus 5 comes from half of negative 10, remember? It's like you are adding a 25 here. So there is a 25 in here. So because we are adding a 25, in order for it to be the same as that, we actually then take away that 25. Okay, because we've added it, it is in this expression, so we take it away. And the only thing that is left is for us to bring that negative 28 back. It becomes positive, and when you clean this up, your particular function is now in vertex form. Let's bring another one. So I have got y equals to q squared plus 12q plus 9. First step is I'll take that 9 to the other side. And then I am going to look at this particular case. The coefficient of the square term is 1. So I can go straight and find half of 12, which is 6. And if I square that, if I do my side work and I say q plus 6 all squared, I'll eventually end up with something like this. Remember now that 36 is in here. It has been added. So I cleverly then just take it away. And the only thing that is left for me is to bring that 9 back, and when you clean that up, you get y equals to q plus 6 all squared minus 27. So let's bring in another question. It is now very interesting because what I have done here now is I have added a value other than 1 in front of the square term. And this is where it becomes quite interesting for us. So when you go and you do, as I said, my method, I first get rid of that 7, moving to one side, okay? And then here now is important because you have a coefficient other than 1. You are supposed to factorize, you take it out. 4 into x squared leaves you with 4. 4 into negative 12 leaves you with negative 3. So this is the part that we are going to now work with. So if I do my side work, I take half of negative 3, which is negative 3 over 2, all right? And when I square that, it actually will give me, if I square that, it will give me some value of 9 over 4. That is why I'm taking all that 9 over 4, like I did with the previous examples. But here's the thing, because I have that 4, I cannot yet bring my 7 back. I will first multiply 4 times that particular number, and it gives me negative 9. And after that, I will bring back the 7, and when I bring back the 7, I'll realize I end up with negative 2. Let's bring in another one here. So what we have here is a coefficient of minus x squared. So the first thing is you get rid of that 21 by taking it to one side. All right. Remember, if they just give you the expression, just feel free to write y equals to, and then you start moving your term. Now I have got a negative 1 that I must factor out. And if I take out the negative 1 into negative 1x squared, I'm left with negative 1 here, and then x squared inside. If I take negative 1 out here, it's going to leave you, and you must be careful here, it's going to leave you with negative 10. So this particular part is the part that we are going to complete the square, the stuff inside here. And half of negative 10 is negative 5. And when you square that answer, there is a 25 in there. So this is x minus 5 all squared. So there's a 25, and that is why I'm taking away that 25. So this negative 1 that I have here, I should multiply that with that 25 before I bring the 21 over. And when you multiply negative 1 times a negative 25, you get a positive number. Now you can bring your 21 back, and you will realize that your final answer is y equals to negative 1 in bracket x plus 5 whole squared plus 4. The negative 1 is the value of a as indicated there. The x minus 5 is what is here. The value of p is negative 5. And the 4 is the value of q. Now your function is in vertex form. I bring in one more. So we have got y equals to minus x squared plus 3x plus 5. Again, I take away my 5, and then again, I have to take out the common factor. When I take out the common factor of negative 1, and then I'm going to be left with x squared, and remember, negative changes the sign inside the bracket, minus 3x. And this is the stuff that I must now complete. Then when I complete that, and I bring in some side work, I just want to show half of this value. Obviously, I know if I bring it to the other side, I must find half of the value of b. Half of negative 3 is negative 3 over 2. And if I square that, I get this 9 over 4 that you can see is here anyway. So what I'm going to have here now is going to be, because I have a value of negative 1 for a, I bring in my square brackets and I have x minus 3 over 2 all squared. But remember, as I said, in this particular expression, the 9 over 4 is there, so I'm taking it out, and then I'm going to multiply that negative 1 with negative 9 over 4, and when I multiply negative 1, I get a positive value, and only now I can bring my 5 over. And when I clean this up here, you're going to end up with y equals to negative 1 x minus 3 halves over all squared plus 29 over 4. You can also go ahead and write this as 7 1/4. The fourth one that we can have a look at is when the coefficient of the square term is a half. So again, we take that negative 2 to the side. All right, and now you must be careful because we are factoring out a fraction. When you do that, you have to look at 3 divided by that 1/2. And you're going to realize you get a 6 there. So I have a little box here that shows that 3 divided by half is 6, and a half divided by half is 1. So you must be careful you don't make a mistake here. So the stuff inside is what we're supposed to complete now. So when we complete that, we find half of 6, which is 3, all right? And if you look at x plus 3 and you square, there is a 9 in here. So when you take this and you expanded, you're going to get a 9 that was added. So I must therefore cleverly take out the 9. But before I do that, I bring in a square bracket because I know that the value of a is not just 1, but it's a half. So I have to multiply that -9 by that half before I bring that 2 over. And when I do that, I can get net -9 over 2 if you multiply half times that. And now I can bring back my 2. And once I do that, I will get a final answer of y equals to a half in bracket x plus 3 all squared minus 13 over 2. I'm going to do the same question later using a different approach. So we are talking about turning points of a parabola. Since I'm not doing graphs now, but it's very wise to have a little talk or to look at what exactly all this means. So the axis of symmetry, so if we have the function, and I bring this function back, this is the function y equals to x squared plus 6x plus 9. The line of symmetry, the line that cuts this parabola in half, that line is x equals to -3. We can actually find that line by looking at the stuff inside here. And once you take that stuff x plus 3 and you equate it to 0, okay, the stuff that is inside here, you equate it to 0, you realize we are ending up with the line of symmetry. Why is this important? Because now, if you take that answer and you substitute that answer for x back into the original function, something very interesting is happening. You are going to get an answer, okay, that gives you the output for the turning point, the y value, the lowest value of the graph, the vertical translation. As you can see, the graph is at 0, so it didn't go up or down. So here was supposed to be x equals to -3 and not an f of x. Let's look clearly at what the turning point means. The turning point is this particular point here, and it's always the x value, which is -3, and then the y value is 0. You can rewrite this also in your vertex form. Now, when you write it back, obviously in the bracket, the sign is slightly different from what you have in the axis of symmetry. This is the only confusion that arises. And whatever the value of y is when you use this particular formula, that is going to be the vertical translation. So I just left it like this, but this final answer is basically just x plus 3 all squared. So the formula we use for the axis of symmetry, this particular line that cuts a parabola in half, is x equals to minus b over 2a, where the b and the a are the values you find when you look at your equation or your function, you write it in standard form, which is mainly ax squared plus bx plus c form. So let's take one more question, actually two, to see if I can apply what I have just introduced. Okay, so what I'm saying is we're going to take the stuff, we're going to take the x symmetry, the axis of symmetry, which is that value of minus b over 2a, minus b here is -40, be careful here, and a is 10. Once you do that, I get x equals to 2. So x equals to 2 is the turning point of the graph. But if I want to write it in that stuff, I will take the opposite value. I'll say x minus 2, because remember this is x equals to 2, and if you take it back, it has to be then minus 2. So let me just write it down. The x equals to 2. This is the value of the axis of symmetry, the axis of symmetry. But if you go back now, you have x minus 2 equals to 0. And this particular stuff is what's going to come inside your particular function there. So once I take that value and I substitute it for x into the function, I'm going to get my value of q. That's the nice thing about using this formula. So you see I've indicated in red, here it's positive, but inside here is negative. Your a you can identify easily, it's 10, and your q is that value that you get once you substitute for f of 2 into every part where there is an x. So let us look at the other example, and we have done this previously. Just by looking at this example, you know that the value of a is 1/2. Okay, so that already takes care of that. You know the value of b is 3. So you can then use your formula, and if you use your formula, okay, which is minus b over 2a, so it's minus 3 for the value of b, and my a is 1, punch this in, you get negative 3. So again, what I expect the stuff to be inside, I expect inside to be x plus 3, because it is the opposite sign. So whatever the sign is, if I am putting it back in here, it's going to be opposite of that. That's the only catch that you have to remember whenever you are dealing with this particular equation. So let us then complete what we have so far. We take that negative 3, which is the turning point, we substitute it, and remember this, back into the function, okay? Everywhere you have an x, you replace that x with that value, and what you're going to get is your output value, which is the value of q. So now all that's left is for you to write it in vertex form. And when you write it in the vertex form, a is a half, x plus 3, always opposite whatever that sign is, all squared, don't forget to square, and minus 13 now over 2, this minus 6.5. This becomes just like that there. So that is how you can do these particular questions. I'll suggest you go back and check the tape again, the video, and get an idea. Try a few more exercises in your textbooks in order for you to be able to master this. Goodbye.